Hi, assalamualaikum and very welcome for those watching this video, especially for Miss Sam, our physics lecturer. So in this video, me and my group members are going to explain about our laboratory experiment of experiment 4, which is linear motion. So let's start with the introduction. So as a physicians, we need to know that linear motion is a fundamental concept in physics that describes any movement of an object along a straight line. So generally, this experiment aims to investigate the principle governing linear motion, including velocity, acceleration, and the relationship between displacement, time, and force. So by studying these factors, it'll help us understand better the dynamics of motion in a straight line and verify key equations of kinematics. Next, the experiment also typically involves observing and analyzing the motion of an object under controlled conditions, which is like in this experiment, we are usually using a glider on an air track. And then we need to be careful and stay alert when using measuring devices such as motion sensors, timers, and photogates because those were used for collect and accurate data. Let's say if your data is not accurate, then your results will be misleading at best and fatal at worst. Last but not least, the primary goal of this experiment is to verify concepts such as constant velocity, accelerated motion, and Newton's laws of motion. So that's all for introduction. Let's move on to objective.
Hi, okay, so for the objective is to investigate the relationship between forces, mass, and acceleration. And for the second one is to determine the acceleration of an object under a varying force. From the theory, we know that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is in the direction of the net force acting on the object, which is we are using the formula the sum of the force equals to the mass times acceleration. Onto the apparatus that you need in this experiment is air track rail. So the air track rail has tiny bit holes in it so that it can blow out air so that we consider there is no friction in this experiment. And you also need gliders with flag to put on the air track rail, and then blows and pressure tube to provide the air, and photo gate to capture the moment when the glider slides through the air track rail and to capture the time it took to reach between the distances, and mass hanger and masses to put on the air track rail and the end of the string and pulley. First, you need to assemble the linear air track set as shown in the picture. Next, switch on the pump to let the air blow through the air track for several minutes, and then balance the track by adjusting the screws on the legs of the air track so that the glider stays stationary and it doesn't glide to another end when it let go. And then you need to insert one hook at the end of the air track rail and a flag on top of your glider, and then measure and record the mass of the hanger and mass of the glider every time you do the same process for different value, and measure the length of the flag, and then attach one string to the end of the glider and also the end of the hanger. Place masses with a mass of 20 gram on the hanger and 80 gram on the glider, and put the string over the pulley. Position the glider exactly before the photo gate, and then release the glider and record the time shown in the photo gate. Important notes: in order to catch the masses from crashing and scattering over the floor. You need someone or your friend to catches the glider before the hanger reach down the floor. And repeat this step 2 times so you can find the average amounts for your data. Then decreases the slotted mass on the glider by 20 grams and transfer it to the hanger. And repeat the step 7 and 8. Repeat this process 3 more times with 20 gram from the slotted mass on the glider added to the hanger.
This is basically the result of our experiment. We can see that the acceleration increases when we put more mass on the hanger. And next, we go to the analysis. First question is to plot the graph of weight force Fn versus acceleration A ms negative 2. The second question, what does the graph tells us? It tells us that weight force Fn is proportional to the acceleration. Question 3 is to calculate the gradient m on the graph. Based on our data and calculation, we got 0.02 kg. Question 4 is to determine the uncertainty of gradient. The uncertainties of gradient that we got is 0.02 plus minus 0.01 kg. Question 5 is to briefly explain the relationship between gradient m on the graph and the total mass. The gradient is equal to the mass of the object, therefore, the mass can be determined from the gradient. The larger the gradient, the greater the mass of the object. This is because a larger force is needed to produce the same acceleration if the mass increased. For the discussion of this experiment, we need to calculate the percentage difference between the gradient m and total mass mt, and to identify the percentage error in this experimental value. Based on our calculation, the percentage difference that we got is 93.55%, and this value can be considered as percentage. We also need to discuss the factor that can contribute errors. First is friction. Some residual friction between the track and glider can still exist, even when using blower or air track. Second is measurement errors. Inaccuracies in measurement, such as masses and time, could affect the calculation for the final answer. Third is environmental factors. Conditions such as temperature and humidity can affect certain sensitive instruments that will lead to inaccuracies in measurement. Finally, to overcome these factors of errors, first, for friction, we need to make sure the air track is clean from any dust or debris. Second, for the measurement errors, we need to double check the measurement to improve accuracy. For the environmental factor, we also need to keep the experiment environmental consistent by controlling factors that can affect measurement.
So, from this experiment, we can conclude that the relationship between force, mass, and acceleration was investigated. What I mean by that is it was observed that the acceleration of an object is directly proportional to the applied force and inversely proportional to its mass, also aligning with Newton's second law of motion, which is F equal to ma, where F is force, m is mass, and a is acceleration. Furthermore, the acceleration of an object varied consistently with changes in the applied force because it really shows the predictable nature of motion under varying forces. So that's the end of our video presentation for today. Thank you so much for watching. I hope you have a nice day. Stay cool and happy. Assalamualaikum.